Kindly subscribe. So in today's session, we will be discussing statistics for business decision. This section will cover populations, samples, sampling technique, types of data and level of measurements. For this section, we will discuss what population and sample is about. The difference between parameter and statistics. Sampling technique and procedures will also be explained. The various types of data will also be explained. The section will also end with what level of measurements is. Population refers to the set of all objects or individuals of interest or the measurements obtained from all objects or individuals of interest. Thus the population is the set of entities under study. A sample is a subset of the population. Thus, taking a part of the population for a study or experiment is called a sample. Census is an enumeration of the entire set of measurements taken from the whole population. Now let's look at the difference between population and sample. In research, the terms population and sample refer to distinct concepts that are central to the process of data collection and analysis. The population encompasses the entire group of individuals or items that are the subject of a research study. It represents the complete set of entities that researchers are interested in studying. For instance, if a study aims to understand the health behaviors of university students in Ghana, the population would include all university students across the country. This broad scope ensures that findings can be generalized to the entire group, but it is often impractical to collect data from every individual within the population due to constraints such as time, cost, and accessibility. Conversely, a sample is a subset of the population selected for participation in the study. It consists of a manageable number of individuals or items that are representative of the larger population. Researchers use samples to draw inferences about the population without having to study everyone. For example, instead of surveying every university student in Ghana, a researcher might select a sample of students from a few universities. By analyzing this sample, researchers aim to make generalizations about the entire population. The effectiveness of this approach relies on the sample being representative of the population, which is often achieved through random sampling methods to minimize bias and ensure that the sample accurately reflects the diversity of the population. Let's look at what parameter and statistics is about. Parameters are numbers that summarize data for an entire population. Thus a parameter is a descriptive numerical measure, such as an average or a proportion, which is computed from an entire population, whereas statistics are numbers that summarize data from a sample, i.e. some subset of the entire population. Thus a statistic is a corresponding measure computed for a sample. The next section is sampling techniques or procedures. Sampling techniques or procedures refers to the approach researchers follow in order to choose a sample from a population. For the purpose of this course, there are two main types of sampling techniques. These include statistical sampling techniques and non-statistical sampling techniques. Statistical sampling techniques refer to the technique that gives respondents equal chance to be part of the study. Subsections of statistical sampling techniques include simple random sampling technique, systematic sampling technique, cluster sampling technique and stratified sampling technique. We will take each technique explain further. Simple random sampling technique, this method involves randomly selecting individuals, often using a random number generator or drawing names from a hat, ensuring that every possible sample of a given size has the same probability of being chosen. This technique minimizes bias and provides a sample that is typically representative of the population, assuming the sample size is sufficiently large. Systematic sampling technique. Systematic sampling involves selecting individuals from a population at regular intervals. Researchers begin by choosing a random starting point and then select every nth individual from a list of the population. For example, if a researcher wants to survey 10% of a population of 1,000, they might start at a random point on the list and select every 10th person. This method is efficient and straightforward, especially when dealing with large populations, but it assumes that the population list does not have any hidden patterns that could bias the sample. Cluster sampling technique. Cluster sampling divides the population into clusters, usually based on geographical areas or natural groupings. A random sample of clusters is then selected, and all individuals within these clusters are included in the study. This technique is useful when the population is large and spread out, as it reduces the cost and effort of data collection by focusing on specific clusters. However, it requires that the clusters are heterogeneous within but homogeneous between to ensure accurate representation. Stratified sampling technique. Stratified sampling involves dividing the population into distinct subgroups, or strata, based on specific characteristics such as age, gender, or income level. A random sample is then drawn from each stratum. This technique ensures that each subgroup is adequately represented in the sample, enhancing the precision of the study, particularly when population subgroups differ significantly in the characteristic of interest. Now let us talk about what a non-statistical sampling technique is about. Non-statistical sampling technique. This is where respondents are not given equal chance to be part of the study. Some of the examples of non-statistical techniques are convenience sampling technique, judgmental sampling technique, and ratio. Now let me take you through the aforementioned non-statistical techniques. Convenience sampling technique. Convenience sampling involves selecting individuals who are easiest to reach or most readily available to participate in the study. This technique is quick and cost-effective but is prone to bias and often results in a sample that is not representative of the population. It is typically used in exploratory research where generalizability is less of a concern. Judgmental sampling technique. Judgmental sampling, also known as purposive sampling, involves the researcher selecting individuals based on their knowledge, expertise, or judgment about who will provide the most valuable information for the study. This technique is often used when the researcher has specific criteria for participant selection and when studying a particular subset of a population. However, it is subject to bias, as the researcher's judgment may not always result in a representative sample. Ratio. In sampling, a ratio can refer to the proportion of the sample size to the population size or the proportion of a particular subgroup within the sample. Understanding these ratios is crucial for ensuring that the sample accurately represents the population's characteristics. Ratio estimation is a statistical technique used to improve the precision of estimates by incorporating auxiliary information about the population. This method can be particularly useful in stratified sampling, where known ratios of strata can enhance the accuracy of results. We are now moving to types of data. There are two main types of data. This includes quantitative data and qualitative data. Quantitative data. Quantitative data is data expressing a certain quantity, amount, or range. Usually, there is measurement units associated with the data, e.g. meters, in the case of the height of a person. It makes sense to set boundary limits to such data, and it is also meaningful to apply arithmetic operations to the data. Qualitative data. Qualitative data is a categorical measurement expressed not in terms of numbers, but rather by means of a natural language description. In statistics, it is often used interchangeably with categorical data. They are defined as the data that approximate and characterize. Other types of data is time series and cross-sectional data. Time series data, a set of consecutive data values observed at successive points in time, e.g., stock price on daily basis for a year. Cross-sectional data, a set of data values observed at a fixed point in time, example bank data about its loan customers. The final topic for this section is level of measurements. There are four main levels of measurements. This includes nominal data, ordinal data, interval, and ratio data. Nominal and ordinal data are known as categorical data. Interval and ratio data are known as continuous data. Nominal data. A nominal scale is a measurement scale, in which numbers serve as tags or labels only, to identify or classify an object. A nominal scale measurement normally deals only with non-numeric, quantitative, variables or where numbers have no value. A common example of nominal data is gender, male and female. Other examples include eye color and hair color. An easy way to remember this type of data is that nominal sounds like named, nominal equals named. Ordinal data, ordinal values represent discrete and ordered units. It is therefore nearly the same as nominal data, except that its ordering matters. Ordinal data is data which is placed into some kind of order or scale. Thus is a scale on which data is shown simply in order of magnitude, since there is no standard of measurement of differences. For instance, a squash ladder is an ordinal scale since one can say only that one person is better than another, but not by how much. Also, age group is an ordinal qualitative variable. An ordinal variable is a categorical variable for which the possible values are ordered. Interval data, interval values represent ordered units that have the same difference. Therefore we speak of interval data when we have a variable that contains numeric values that are ordered and where we know the exact differences between the values. Thus interval scales are numeric scales in which we know both the order and the exact differences between the values. The classical example of an interval scale is Celsius temperature because the difference between each value is the same. Ratio data, ratio scales are the measurement scales that tell us about the order, the exact value between units, and also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied. Everything above about interval data applies to ratio scales, plus the fact that ratio scales have a clear definition of zero. Good examples of ratio variables include height and weight. Note, interval scales don't have a true zero. For example, there is no such thing as no temperature, at least not with Celsius. This brings us to the end of the lessons. The channel is TechByte Insight. Kindly subscribe. See you in the next lesson. Thank you.